So my name is Steve Swartz. I'm an architect on the Connected Systems division at Microsoft. I've been there about 10 years. I was a dev and a dev lead on the Com Plus and MTS teams. And then I saw the light and became a PM and then an architect. If you ever work at Microsoft, the trick is you never want to be a junior PM because you have to do all sort of horrible process work. But you never want to be a senior dev because they still make you fix bugs in a hurry at the 11th hour. This is Clemens. He's my good friend who I met at TechEd Europe 6 or 7 years ago.
Yeah.
We have now convinced him to work at Microsoft, where he's working on...
It took about 6 or 7 years to do so.
A lot of badgering.
That's true.
Yeah, but you finally wore down. And get married and all that grown-up stuff.
Yeah.
And anyways, now we're talking about identity. We're in the middle of 6 talks. We're actually towards the end. This is the last day. Gave 2 on Tuesday, 2 on Wednesday, 2 today. The first talk was kind of a review of all the products that our division has to try to give you a clear view of how they all fit together. Talks 2 through 5 are architecture talks, where we're going through the main areas that architects have to think about when they build a big connected system. And the talk we're giving later today, number 6, is looking forward, trying to give you an initial roadmap kind of view of what we're thinking about doing over the next few years. Since we're not announcing any future plans yet, it's a talk that you're guaranteed to come to and then say it was too vague, even after I tell you it's going to be vague before you show up. But this talk is about security. And it's a little bit unlike the previous talk because while we're going to start talking about patterns, the big trick in security is to actually understand the story. For those of you who have been following Kim Cameron's blog and thinking about how the world of security is changing, the story that organizes our thinking about security is very different these days. We're changing from a world that's focused mostly on ACLs and identity to a world that's focused on claims. And so this talk is going to have 3 parts like our other talks have, but they're going to be a little different. The first part of the talk, we're going to go through the story of security. And we're going to talk about the main ideas that you should think about when you're organizing the security part of your applications. Then in the second part, we're going to go back and map those ideas into the way they're implemented in the world to ground these ideas in experience. And then as we've done in the previous talks, we're going to go back through and do scenarios.
And just like the previous talks, especially the presentation one, this one is not going to tell you, as much as the presentation talk didn't talk about how to do particular things in Avalon, this one will not go and drill into the details of how you do encryption in particular in the Windows Communication Foundation.
Yes, my observation of a task we have not at an architectural level but at a framework level as we move forward is, if you think about transactions, MTS and Com Plus and Enterprise Services and now WCF have actually simplified the business of doing basic applications so that a person that doesn't know a lot about the particulars of ACID and so on can still do a reasonable job putting together a transacted app. Whereas my own experience as a guy who hates thinking about nonces and X510 or 509 or whatever it is that you have to know a lot of the details of security before you even get going programming our system. And so one of the goals we have is to make security more approachable coming forward so that you can deal with it without understanding the details of the mechanisms. And a part of this talk is to try to show you the story that we're thinking about organizing our product around. So let's start with patterns. The whole world of security counts on the fact that there's a bunch of mathematicians who spend their life coming up with mathematical tricks that make doing secure things possible. And one of the mathematical tricks they've come up with is this. I can sit in my room at work and I can use a mathematical function to come up with 2 numbers. And the trick about those 2 numbers is that if I take one of them and take some data, I can encrypt it, and it can only be unencrypted if you know the other number. And so these 2 numbers are a mathematical trick that let me do security with you without having anyone else involved. Now, there's fancier mechanisms, so I'm not talking about optimization. I'm trying to just establish the possibility of doing secret talk. And the way I deal with these 2 numbers is this. I keep one of them secret so no one ever knows it but me, and I put the other one out on my door. And when you go and get the one that's on my door, we can now do two things. If you send me a message, you know that I'm the only person that can read it, because you've encrypted it with the public number on the door, and I can decrypt it with the one I have, and so I'm the only person in the world that can read that message. Whereas if I create a message with my secret key and give it to you, you don't know anyone in the world can read it, but you can tell that I created it. And so this secret business at the beginning lets me do two things. The person with the secret can establish something. It can either establish that I'm the only one that can read it, or I'm the only one that can send it. And the person with the public thing can just deal with those two directions. And most of the other security mechanisms work that way. They're not really about anything other than establishing the ability to share secrets. And so you can kind of float above the particular mechanism and just know that this is possible. You and I, with nobody else involved, can share secrets. Now, they say that on the internet, you never know whether you're talking to a dog or a person. And that's true. And my boss, when he goes out and talks about this, will say he doesn't really care about whether it's a dog or a person that his kids are talking to. He just wants to make sure it's a nice dog. Yes. But making statements about whether or not you're a nice dog, or whether you're an adult, or whether or not you're actually you, that can never be done with this business of exchanging secrets. Right? Because if I can exchange a secret with you, the content of the secret can be anything, and there's no judge of that. So it's a big difference between the mechanisms that are needed to exchange secrets and the mechanisms that are needed to confirm the truth of some secret. And the only way you can confirm the truth of some secret is having some authority figure. Since Clemens comes from a police-oriented state, he makes his authority a police person. And so the thing is that we have to do two things here. This person can talk to me secretly and ask me for some confirmation of who I am. They don't trust me from Adam, but I can go to the trusted being in the sky, talking to them secretly using the secret mechanism. And I can say to the trusted being, give me something that'll prove that I'm me. And the way that that works is I've gone to the trusted being before in person, or I've sent a lawyer, or however I do this. And I've said, trusted being, here I am. You can take my fingerprint. You know it's me. And then they give me some magic cookie. And the trusted being knows that the only person who has that magic cookie is me. And so if I use that magic cookie to encrypt things that says I'm me, I can give that to this person. And this person can go to the trusted being and say, okay, I got this stuff. What do you think? And the trusted being puts their stamp on it. So the point is we can talk secretly to one another all by ourselves. But in order to talk the truth, in order to talk some verifiable assertion, we need an authority. And in the secret world, there's usually a chain of authorities, right? Like within my company, Microsoft, Microsoft is the authority. And we can all communicate amongst ourselves, but in order to verify that I'm actually Steve Swartz, I got to go to the Active Directory authority, where we've arranged my my badge and some secret numbers that I can always promise that they'll tell it's me.
What's interesting is that you can ground all those patterns really very often in the real world. Like this would be the United States, or you being a passport holder of the United States. You have the border of Spain or Germany, right? And you come with your passport, and only because there's belief by the Spanish authorities that the US government will only give passports to you if you're a proper citizen. Only through that you can actually get in. Mm-hmm.
And so this is just generally true. We can talk amongst each other, and I can say any sort of nonsense, and you can tell it's from me.
Sure.
But to prove that the nonsense is true, you got to go to some higher authority.
Yeah.
Now, typically when I'm going to talk to someone else a lot, I don't want to constantly be having them come to my door and getting the number and so on. In fact, I want to establish some relationship with them that lasts a long time. And so it turns out that once we have this ability to establish a one-way communication between you and I, where you know it's me, and you know that I'm the only one that can read these things, if we share that stuff, we start communicating and then we share these cookies amongst ourselves, we can end up with a combination of two numbers that let us communicate with each other in such a way that we both know it's each other, and we both know that only each other can read things. And so for anybody that I want to talk to for an extended period of time, I store these two secrets, and of course, I'm just using the simple two-secret rule. There are other ways of doing this. But I store these two secrets, and then I've established a permanent way to talk with you, and you talk with me. Right? So there's a way that I can, on the fly, create these things, but I want to keep them around if we're going to talk over and over, because in fact, the mathematicians have all sort of other things that I can do to make these far more useful and fast and secure. But we can establish that, and we can end up with a ticket on each side of the conversation, so that I still can't verify the truth of what I'm saying without going to the authority, but we can talk for a long, long time, as long as we're willing to trust these secrets. So what happens is that I end up with a whole passel of these secrets sitting in the floor or in a file cabinet in my office or on a disk file at work, one for each of the people that I want to establish a connection with. And I just keep them all, and then anytime I want to talk with some particular person, I'd look through my file cabinet. They may say, oh, my name is Bob, and I have a nice simple way of looking up these secrets and finding the one that's Bob. And then I begin to talk to Bob with that secret. And sometimes the secrets are really simple and easy to break, like a username and a password. Sometimes in the real world, we have a tendency to use the same secret to talk to lots of different people, which we can do if they're simple secrets. But you end up with this pile of secrets. And you have a secret for each thing. Back in the days, those were called credentials, and we had them sitting around. And when I wanted to talk to a new service, I had to bring the credential down and set it up on my bucket of secrets. And that became yet another administrative problem in dealing with a connected system. The point is that everybody who wants to talk has a set of these secrets. So we can talk to each other, we can do truth checking, and we can establish this bundle of secrets that lets us talk to people. Well, it turns out that managing those secrets is a pain in the neck.
At least.
Clemens.
Sorry.
Now, I want you to only interrupt me when you have something constructive to add, because certainly I never throw a comment into these conversations unless it's constructive.
Yes, I'm sorry.
Thank you very much. So what happens is that you've got all these secrets sitting around, and they get kind of tedious to take care of. And what you really want is some module somewhere, some bucket that you can grab a hold of, where you put all the secrets. And then what happens is that when you want to talk to Mary over here, Mary says, I'm Mary. And all you got to do is go to the third party and say, give me the secret for Mary. And then you commence to talk. And the advantage of that is that the secrets are no longer sitting in your file cabinet where they're not so secure and they can be taken by somebody. They're being managed efficiently in some central place. I can go and look at what secrets are there. If I have to audit what secrets I need, I know where they're at. Since the secrets are in a software place now, a central place, I can automate the using of them. I think for a while there was a big cottage industry and people handing out software that pretended to take care of your secrets, but then sent all of that and your credit card number off to some central place. So you want to make sure you trust the person who's building these secret buckets, right? And it was a natural evolution of the software business to be able to establish these buckets of secrets. Now what happens is this. In the real world, what I want to be able to do is talk to one of the people I have a secret claim to and send them information that can be trusted. For example, I want to go and buy a t-shirt at my favorite t-shirt vendor site. And so I want now to be able to send them a secret that has my credit card number in it. Now today when I send my credit card number out, I've been trained to do this. And so whenever anybody on the web asks me for my credit card, I either behave like my dad and say, I'm never going to buy anything on the web, I don't want to, Or you're like me, where, okay, I'll type it in, who knows who you are. People worry about leaving their credit card behind at a restaurant. Just imagine I bought a DVD the other day of the original Batman series.
Oh, yeah.
And I only found out later that it was a bootleg, and I was very embarrassed.
It was.
But then I said, what did it mean that I just sent my credit card number to someone who was so illegal that they were able to, then I realized they were Canadians, and so I wasn't worried anymore. They thought they were doing a service in some hip way, I'm sure. But the point is, I need to be able to send secrets to people, and I have to make sure that they are both secret and somehow that their content has been validated. And so at that point, I end up mixing up my bucket of secrets with the authority. Right? I've got a bucket of secrets that I have that let me talk to people, and I have an authority somewhere in the world who has to validate the data I'm sending. And so there is the mechanism that we need to use in the world, some authority that we all agree to, and the ability to use this public-private secret thing to send a document to them that has just the data I want.
And it's endorsed data by that third party.
Right. And so the ideal thing would be if that third party, let's say they were Visa, could endorse the fact that this is in fact my credit card number, but also encrypt it with the secret of their own, so that when I sent it to the DVD company, they could send it on to Visa and use it, but they wouldn't actually know it. And they couldn't use it in any case other than in a transaction between me and them, because it would be encrypted in such a way that Visa would only decrypt it if it had been sent by me.
And you can use it in a three-way secret way where you have A, the current transaction, B, the cardholder, and then C, Visa. So you can make with that combination, you can make a one-way transaction code that will not be valid in any way for any other transaction, unlike the credit card number now.
More to the point, I don't even need to send you right now. When I talk to these people, they know who I am. And they really don't care who I am. They just need to know that Visa is willing to give them money. And so in the future, I can send that information to them that's secret in a way only Visa can read. They don't even know anything about me other than what they need to know.
Because the only thing they really need to know is that there's money there that they can get at. Because one of the weaknesses that we have currently in the whole electronic payment story is that, of course, you don't have the same quality as cash. Right? You can walk into a store, you can give them just a few euros, and that's fine, but they can't track it. They don't know who you are. So you're an anonymous customer, and very often you want to be an anonymous customer.
I always like to get to know those people, but that's from being from the Midwest, where I talk with everybody. But generally speaking, you're right. What we're trying to do with this mechanism is separate out the particular bits of information you need to share and which ones need to be validated. So you see where we're coming. We now are talking about a mechanism that lets us give particular pieces of information in a trustworthy way and in a secret way to clients. Now, one of the things that happens once we end up having an authority is that we can merge the job of the authority and the ticket holder into one. And what we do there is we have a big bucket in the sky that we all use. We might mean everybody at your house. It might mean everybody at work. But what you do is you take all the tokens you need and put them up there. And then all that needs to happen is each of the people working here that are wanting to talk in the domain of this central authority, all they need to do is to have a secret relationship with the central party. And so if I have a secret relationship with the authority and you have a secret relationship with the authority, all I need to do is to go say to the authority, I'm about to talk to you, and it will give me a secret that's only good for this one time talking to you. And then when it gets to you, you can go back to the authority and it can help you figure out what just happened. So now I've relieved myself of the need to have a bucket of tokens and a need to have authority and just have one central place. And it turns out whenever there's a bunch of people working together for a long period of time, it's tremendously efficient to have this central place that everyone trusts. And if you look at the history of security, we found out that nobody's really willing to have a central authority that everyone trusts at internet scope, because we don't want there to be one thing that owns all those. So out in internet scope, we're all still dealing with our own secrets. But at company scope, since most of the things we do there are company things, we don't mind centralizing the authorities, an authoritative central store of these things for our enterprise.
And it's, of course, very handy because if you have multiple machines or if you're just getting a new machine, all of your because all that secret management is really difficult and you need to have all those mechanisms. You want to have a place that just keeps track of all those, and if you set up your new machine, you just get access to your secrets again.
And I've experienced this change over the last several years when I've gone through the change that we've gone through with Active Directory, where 5 or 6 years ago, whenever I installed a new application on my system, that involved going somewhere and getting the certificate I needed to use it. Whereas now Active Directory's got to the place that I never find myself doing that. It's got security groups in place that all I need to do is talk to it, and it can manage this whole thing. But that goes ahead to your talk, and I'm part of the talk, and I apologize.
That's okay.
Okay. So it turns out that whereas sometimes I'm communicating with other people and I need to make secrets and send to them, far more often in connected applications, what I'm trying to do is to access a resource. And because I've got all of those secrets in that central place, what's typically happened in the past is that we've set up a thing called ACLs, where I basically just have one secret, which is who I am.
Can I just spell that out? Access control lists.
Access control list, ACLs. And so what happens over here is that this guy in the corner can establish that he is Sam. And he can establish that he is Sam by going to that central place and getting back a ticket that asserts that according to the purple authority, he is Sam. And then what happens is that every single resource in the world sets up a wall, and it knows all the identities in a list that's local to it that can come through. And so it knows that Sam and Mary and Peter and Jane can access the disk. Along comes Sam. This guy says, is this in fact Sam? And the purple thing says yes, and then it's allowed in. And this was security as of just like a few years ago, or in fact, pretty common today.
Yeah, if you look at managing your disk and you want to give particular permissions to people, inside your company, you find yourself, I'm always struggling with getting the access control lists right for the people who are on my team, and then I have additional people from other teams who need to go and get my files. But I'm working on things that are fairly secret, so I can't just share them out with the entire company, so it's always a struggle, and you need to apply those to directories and to the files in the directories, because the files may be then shared out somewhere else, or you may copy them, the access need to go along with them, so it's really difficult.
And that's because once we get to these central things, the only secrets they were able to communicate, the only secrets they were keeping track of is who we were. We all establish our relationship with the purple box, and the only relationship that's there is, who are you? And that's what we were talking about earlier. In the network today, there's only a username password secret, and then I have to send my address and my social security number and my credit card number, all wrapped up in one secret, available to anyone who knows the secret. And so the big innovation that's happening right now, most of what we've talked about has been happening over a period of time. The big innovation that's happening now is separating out the world of claims. And claim is just a word to say, instead of having a secret, which is encrypted, and the thing that matters is how you encrypt it, a claim is one of these trusted assertions, where there's some authority that says, yes, I'm promising the truth of this claim, and then the claim can be sent secret to anyone else. Now, the authorities can be anybody. Like, for instance, if I'm talking to a website, they're quite happy to have the authority be me. And so all I'm doing is saying, I'm going to tell you that I'm 18, but I'm going to do it on my own authority. On the other hand, I can have an authority where I make an assertion that says, I have a company, and VeriSign, who is the ultimate authority in the computer world, or one of them, says, yes, I agree, that's them. And there's all manner of intermediate authorities where there's a certain amount of trust in them, and they can be trusted to assert certain things. But the trick is that now that instead of walking up and telling this thing, oh, I need to use that disk because I'm Sam, I bring a claim along that says, I can use the disk. And that's a beautiful thing architecturally. Because no longer when I'm building a system do I have to set up users and groups when I'm designing a service and have all those things that say, mapping those users into sophisticated business logic, I can in fact say the only person who could ask this disk is people who I will let access this disk. Or I might say the only people who can access this disk are managers in this team, or people who have worked at the company longer than 7 years, or any other rule.
So claims are really just endorsed facts, and they may be really little. So I can imagine one of those facts, make just a little one, is my office number. So my office location is in building 42, and in a particular room there. And if you were willing to make a share that's only available to people who are in building 42, you would state that authorization fact over here. You'd say, this is only available to people who are in building 42, and here I come along with my claim that's endorsed by the Human Resources Department, which says, yes, his office number is 42, and I can just check that fact against that rule, and so I can come in. And as the Human Resources Department, along with my team, moves me to a different building, well, then that's up to them to manage, but I no longer have that claim in my hand. I then have a different claim of building 1, so I no longer can get there. But just so the authorization, the grounds for the authorization, the basis for it is no longer my identity, but just the fact that I have a data item in my possession that is endorsed by the Human Resources Department, which says your office is in building 42.
And so what happens as an architect is that when you're looking at all the resources and services in your application, your whole thinking changes. And you begin making assertions that are valid for this application rather than users and roles. And you say, okay, I may have only 5 assertions that matter in this whole application. The assertions might be about my job, or it might be about my function, or it might be about some category that I'm in relative to the application. And like I said, then these rules at the wall, instead of becoming identity-based, are business rules about assertions relative to your application. And so the major architectural changes is now you're dealing with the identity and access part of your application design in terms of these guaranteed facts, which are application-specific and have nothing to do with identity.
And so once you start to make that shift and you think about the facts of life that you can test against for an authorization system, once you start to decouple identity really from the facts that you can go against, and you think about having a rule system around this, once you get your head around it, it's very liberating, and you can think about authorization in a completely different way. So let's say you have a marketing system. That's part of the thing, the video that I'm going to post after the show, after I've done a little work on it. We have a service in that big thing that I showed in the Logic talk that's about marketing. It's about setting up promotions. An authorization on that service could be, you are allowed by an executive vice president of the company to set up promotions of up to $20,000 or up to $30,000. So you really have a business rule that gives you access or not access to that functionality. Because you can bring along those claims, you can bring along facts about who you are, and not who you are, but actually what has been given to you as permissions or as rights by the company, as authorizations really on the business level, and you can check those now on the technology level. You can actually use business rules to grant access, and that's something we can't do with a simple identity-based scheme.
Now, in order to implement this kind of thing, what we found is you need to separate out the identity part of the world, which is the authority that generates the assertions about the truth of claims, from the management of claims themselves. And so in the software, what you'll see is an authority who deals with identity, and then an authorization manager who deals with access. In fact, what you're going to see is that the teams are going to, it's hard to get people to even use the word security anymore in our world. In order to make this point that we're separating security into the management of identities and then the management of access, the teams are now called identity and access. And we talk about authentication when we're dealing with identities, and authorization when we're dealing with access. But you really want, as an architect, to stop thinking about those two as if they're the same problem.
And that they're not as immediately connected as, you have a service, you authorize, you authenticate, and then you authorize, like as two steps in the same thing. But really, they're completely different spheres of concern.
Now, there's one last step that gets in here, and then we're going to be done telling the story. And then, instead of interrupting me constantly, Clemens will be able to carry the baton himself. Not that I'm grumpy that you keep interrupting me.
Are you?
No, of course not. I never get grumpy.
You seem like it right now.
Really? You think I'm grumpy?
Yeah.
Watch this. See, that's relaxed.
Ah.
This is grumpy.
Okay.
You could tell the difference.
No, you have this slight,
You know something? It's just because I'm tired. This is a long way from home, and the clock always rings at the wrong time. I think you're mistaking that for grumpiness. So you've seen me grumpy before.
So there's still harmony and love?
Oh, Clemens. How could I ever stop feeling that way with you?
Okay, that's good. So talk about that.
I have put up with a lot worse from you, for instance.
That's true.
Yeah,
You've been talking about my bald spot.
Yeah, but I don't have anything like that you can talk about. My hair is still fine up here, for instance.
It's true.
I can grow a full beard.
I can grow a full beard too, and I may actually end up
But you can make babies, and I apparently have never figured it out. So it's all okay.
That's an incredible skill.
I bet it's a fun one to have as well.
Yeah. Well, making them is a lot of fun too.
Oh, there you go.
Yeah.
Raising them, you'll find, is equally fun.
I'm sure.
And you're going to find your alarm clock not working well for several years.
So
let's go back to the story.
Yeah. So he has a set of things that he.
See, now you're interrupting me so much, you're not even letting me start the story before you begin.
I'm just trying to give you.
Why don't you go back and have a drink?
I'm just trying to give you a start.
I've been here before.
Okay.
Where were we? So, see. So we have now these two parts. We have a directory, which is the authority we go to when we're talking. And we have this authorization manager, who is the person that manages the claims based on those authorities. Now that's fine so long as we're all sitting in a world where there's one directory. And 5 or 6 years ago when we started Passport, I think we were hoping that we could establish a central directory. But that doesn't work out. That doesn't suit the marketplace. So one of the things that's been evolving with our WS Star work and with Kim's thinking about identity is this notion that you want to have very central in your architecture here, the notion of federation. And you've heard me talk before about federation. We want to embrace the fact that the world is diverse. And so instead of there needing to be a central location where all the authority is, how do two different authorities work? And so we add a third person to this thing, the third software module, in addition to the directory that manages identities, and the authorization manager that manages claims. We have a federation manager. And here's how the federation manager works. I'll give you a very concrete example. I'm sitting here working on WS Star specs. Can I do this?
Yeah, you can do this.
Okay. So I'm working on WS Star specs. We used to work on this with IBM and BEA and a bunch of other companies. And we had those specs on disks in all of our machines. And at the very beginning, before we had even worked through these security standards that are necessary to play this federation game, what would happen is that all of us in each company that were working on the specs would have to have an account at every company that gave us access, because we were doing identity-based access through ACLs. So at IBM, I had a login and a password that I could use to get to the machines that had the specs. Well, as you can imagine, this is a really horrible problem when you have many companies and people who work on standards are flighty creatures. They keep coming and going, working for one company or another. And when someone would leave a company, you suddenly had to make a phone call to all the other people and say, oops, no longer can, you better get rid of these accounts, right? So they ended up having this mailing list where they every day had to worry about these issues of managing. Because, of course, there's hundreds of people dealing with these things. So here's how the federation manager works. They establish a claim requirement over on this disk that says, you can only get access to this disk if you are allowed to work on WS Star specs. Okay? And then there's a federation manager that makes a deal with other federation managers that says this. If somebody arrives with a claim from Microsoft at IBM's disk and says, I have the right to work on WS star disks, instead of the disk going up to the authorization manager and saying, oh, does this person have that claim? Instead it goes to the federation manager because it sees the claim is from Microsoft and it says, federation manager, will you go check with Microsoft to make sure this claim is okay? The federation manager talks to the Microsoft federation manager and says, is this a claim you got? And the Microsoft federation manager says, yep, it's good. And back we go. So over at Microsoft, they manage the mapping from the Microsoft identities to the claims. Microsoft was the only one worried about who had the claim. And that's obviously a reasonable thing for Microsoft to do because they knew who was working on this project. Microsoft and IBM only had to agree on one thing. IBM has to say, we trust you, Microsoft, to decide who's working on this project. Because we all are, I don't trust you to get on to log into my machines, to go snooping around in all the sources of our software, but I trust you for the claim of who can work on the WS star specs. And so the upshot is that the federation manager only makes one deal, and it's a precise deal that says you guys over there can come up with these claim assertions. And so all the security is right. Now what happens is identity and claim access is where it belongs at Microsoft, and the IBM is able to guard their disk. IBM can decide who they let have that claim, and they can grant Microsoft the right to make that decision. So now that is actually all the pieces we need to solve this puzzle. We need a piece that takes care of identities. We need a piece that takes care of granting our claims based on those identities or on other claims. And then we need a piece that makes agreements with faraway things who we only trust a little bit to work these deals when the claims need to be federated across multiple sources of authority. And so there's the story. We went from a simple 25-year-old ability in Emacs to use text mail and encrypt it with pretty good privacy. We walked through this story up to the place where we have a modern system where everything is based on just getting the identity right. The goal here in this is to provide architects with the ability to reason just about the part of the identity system they need to. And so the reason that we present this in terms of a story is that I think what you need to do right now is get your head around this story. To get clear as we go through these steps, what this means to you architecting applications. You need to think about identities in a very serious way, probably becoming more and more secure in your ability to establish the identity of people at your company, better than username passwords when you're wandering around the world. But then you have to think separately about claims and about federation. You can have as small a domains of identity as you want, and then you need to have application-specific claims managed in a central place. Now, Clemens, of course, I'm going to remain quiet the whole rest of the talk and not bother you at all to show you respect.
So you are grumpy.
No.
Okay. So we're going to talk a little bit about the implementation of those things. How do those things work? Now, a really interesting feature of Windows is that it actually implements quite a bit of the security infrastructure for you. I still see a lot of applications which have a username and a password built into a database. All of these applications do not participate in all of those mechanisms because they try to build their own complete security infrastructure and they just cannot benefit from the features which you get for free in the platform because they're already there. So there are, the simplest thing is the password, and that's what you can do. But then as you go up the security ladder, if you make better authentication mechanisms, let's talk about those first. You have to deal with devices, you have to create drivers, so all the work that has already been done in the operating system, you have to do yourself, and that seems a little silly to me. So with Windows, you get mechanisms such as the fingerprinting ability by just buying devices, keyboards that have that built in. There's drivers for those. You can plug that straight into Windows, and it just works. And that will go and take your secret that you have, your fingerprint, and associate that with another secret. We're going to get to that in a little moment. We have the ability to go and secure, with the Windows identity, secure access to operating system resources. We have the ability built in to use cryptography, and use cryptography that's tightly coupled to the identity you've established with the operating system, and your application being able to use those cryptography features directly for its use. And of course, you have to have the ability to create groups, to create groups in Active Directory or on the local machine. So there's a lot of features specifically in the authentication realm, which you already get with Windows straight away. In the network, and that goes back to the first talk that we had, we have a simple model, which I still call the NT domain user store, which is really the workgroup identity, where you have workgroup and everybody has the same kind of username and password, and the username and password may even exist on every single machine. And just by creating the same hash ID password, you just get access to those things. Or you have just one domain store where your username and some passwords are stored. And then we went and built out Active Directory, and Active Directory gives you the capabilities that we talked about as a common security store. So the benefits you get from Active Directory is what we talked about earlier in our story, is you don't have to reestablish all the credentials again and again and again. You don't need to go and populate your local store on the machine. You don't need to provision that, but rather Active Directory keeps those things for you. Then the next part that's very important for those applications that still have username and password is Identity Integration Server. And the Identity Integration Server, or those services offered, allow you to go and synchronize secrets from Active Directory or to Active Directory, which for applications which don't have that capability. So if you need to have things like single sign-on to applications which still use username and password, you can go and propagate those things out to those apps, or you can propagate information from those apps into Active Directory, and so synchronize your whole identity story and properties that you have, and properties that belong to you as the office address that I talked about, may be claims that you can use in a sophisticated authorization scheme that's claims-based. So what Identity Integration Server does is two things. First of all, it synchronizes, if you wish, usernames and passwords, but it really starts synchronizing and negotiating any sort of information that's associated with any sort of Active Directory record, if you will. So it's a very sophisticated, specialized identity integration engine. And that's really important when we get into claims-based authentication, authorization, because claims are just facts of the business that you can run rules on. Hello? Oops. Now we have the situation that we actually, well, we're going to get to those points.
Would you like me to go backwards for you, Clemens?
No, well,
I can go do it.
I think I can't.
I don't think you're going to have any luck.
I think I'm going to.
But I'd like to go backwards. I live to serve you in every way I can, Clemens. You're just trigger happy. Here, you just stop clicking for a second, okay?
Yeah, thank you. And then we have additional services like CardSpace, which actually implements this story of claims, which gives you, and if you open up CardSpace in Vista, or if you install the .NET Framework 3.0, you find on the control panel a little new icon which says CardSpace. And if you open that, you can create your own cards, and you can enter lines of data, your first name, last name, date of birth, and your location, etc. And every line of data is a claim, And you can make decisions of whether you're willing to give those claims out to someone else. People can give you the authority to use a certain claim. Like your credit card company gives you maybe 3 claims. That may be your card number, a card verification number, and an expiration date. These are 3 claims which are added to your identity, which you're authorized to use as long as the credit card company has not revoked your card. And that doesn't work in the way as it works with stuff like certificates, in that you have a revocation service, and it will be looked up there. But actually, every time you use that card, you will walk up really to Visa, and they will endorse those claims. Active Directory Federation Services also is all about claims. Also is all about those bits of data that we are flowing back and forth with identity integration services, which we can personally manage with CardSpace. And Active Directory Federation Services goes and now federates and translates those claims between companies. And that's the exact story that we just had. That's really the separation. Active Directory Federation Services is that federation service that Steve just talked about. So in the network, we have a fairly complete infrastructure. I'm just going to go and now in detail map those things all out. So the first pattern, so now I'm going to go through all the patterns again that we had and just make them very concrete and ground them in the technology that we have at hand to realize them. So the first thing we talked about was the secrets. And just the secret story, that's just like pretty good privacy. That not so popular anymore, but good, email encryption story. Up until a few years ago, you had very many people who were using PGP keys and would append them to every email. And they would have 2 pieces. They would give out their PGP key, and they would also have a PGP signature under each email, which you could then use with the PGP program to feed in the public key and to feed in the email along with the signature, and that was all text-based. And with that, you could actually check whether the email was genuine and not changed, and whether it was really from that person. Because the person held onto their private key, and the receiver would know the public key. It was posted on the wall. It actually came straight with the email. And that established that identity that it's from them. And then if you wanted to send them private email, you could take that public key and just send it back. It's just difficult to manage all those things, because for a one-to-one relationship, that's really easy. But for a one-to-n, end-to-end relationship, that's really hard. How do you remember all those keys? And that's what required, so PGP really required the PGP application to just manage all those things, which makes it really hard. X509 is based on that same idea, but while in PGP you just make up your key and give it to someone, so you can know that it is from a certain someone, but you really still cannot tell whether it's a dog or a human or a nice dog. X509 added the certification of individuals. All of a sudden, you had an authority which was there to verify the identity of people. So for VeriSign, for instance, that's one company which is doing that sort of signature, but there's very many others. For them to establish identity, their procedure is, for simple certificates for people, is if you're willing to give me money along with your name, well, then you must be real.
That works in a rich country.
Yes.
Money talks.
Yes.
But that's not true here in Europe, where you have higher standards, right?
That's true everywhere, because you don't really have much choice in the certificate market.
So capitalism is even better at getting out into the world than the American way of hamburgers at McDonald's.
I think it goes along. I think McDonald's is actually doing better than that.
You think?
Yeah.
More people eat McDonald's than get security from VeriSign?
I think there was McDonald's in Moscow before the wall came down.
Wow.
And so you can't really see that being as a capitalist place back then.
I bet Marriott had the franchise. because they had all of the hotels and everything. That was the first guy over from America.
Oh, really? Interesting. So X509 adds that certification authority up there, and you have a traceable certification path. You bring in a certificate. The certificate is signed by an authority, which is signed by an authority, which is signed by an authority. So VeriSign gives Microsoft. VeriSign is the most trusted being there is, for whatever reason. You know, apparently that's there's some great being up in the heavens, and then there's immediately VeriSign.
You look like you're doing ballet.
Actually, yes. So, and VeriSign gives Microsoft the authority to create certificates for their own customers or for their own employees. And then Microsoft endorses those employee certificates, so you have two levels of trust up. So all these things are signed. One of the problems with those things is those certificates have expiration times, but if you want to revoke them, so you no longer want to give that authority, you need to go to some obscure service, which then has all the invalid certificates, and that makes the story really slow. HTTPS and also W-Secure Conversation are using an optimization mechanism for longer running secure conversations. So you have this private and public key business where you're having a 3-time handshake in all of these things, where you're establishing 2 sets of private and public keys. And once you've established those 2 sets, sometimes, and that really depends on your security requirements, this is used, the public and private keys need to be certificate-based, need to be trust-based in the way with the 509 certificates, just so that you know that the party you're talking to is real. Sometimes you just don't care about that and say, I just want to make sure that nobody can see what's going on in the wire here. Sometimes you use HTTPS in a very secure fashion where you must have a known client certificate and you must have a known service certificate, and only if those two match up, if only if those two are known, then you're able to talk. So these are all authentication issues that have to do with HTTPS, for instance, which are not really required to do that sort of thing here. The key in W-Secure Conversation, the key in HTTPS to make the conversation by itself secret is that we have 2 of those pairs, and the pairs are used to exchange one shared symmetric secret, which is then used to encrypt the packets that go across the wire, so that both parties know one key, and you can use a much, much faster algorithm to encrypt the data that goes across the wire. So while HTTPS is the session setup is public-private key-based, the actual session during the session, all the secrets are being sent around using a symmetric key. And the same is true for W-Secure Conversation. The difference here is that in W-Secure Conversation, there's actually, by the spec an option to go and first use the public-private key story as you're sending the first application messages, and then fall back to a cheaper mechanism once that's established. Then the next pattern here is the trusted store, the trusted third party, where we hold things. Since we know it's really difficult to manage all the secrets, what we're doing is we're entrusting them to a third party. Third party may just be a piece of software that operates on your machine. So we have a personal certificate store that sits in our Windows box, a personal certificate store that sits up in Active Directory because it turns out that those things are synchronized up. We have information cards in card space, and that's also a secure wallet that stores stuff for us. And BizTalk SSO, or HIS, Host Integration Services SSO, which happens to be almost the same service, is holding credentials for us when we want to talk to other applications. What BizTalk SSO does is you walk up to it and you authenticate, and you will unlock a digital locker, and the digital locker holds your username and your password in a different system. So we'll go against that. Managed information card, that's what we talked about that's what card space is all about. Card space is like the credit card you have in your wallet, or provides a managed card is like the credit card you have in your wallet. It's given to you by Visa or MasterCard or American Express, which gives you an implicit endorsement, and they give that to you, and now you can use that card in any store that accepts Visa or MasterCard and American Express, and they will let you pay with it. And that sort of endorsement, and this goes for, we have lots and lots of use cases for that in the real world. Like you have your auto club card, and your car breaks down on the highway. You can call the service line of your auto club, and they come by and they will tow you off the street, and they probably will repair your car, and you don't have to pay anything for it because you have that card that shows that you're a member of that club. So managed cards are cards that are given to you by some organization that are willing to endorse a certain set of claims, like membership in that club, like being able to pay until a certain date, et cetera, et cetera. So that's the story, the real story here. And what we're doing with information cards, with managed information cards, and we're taking this real life story, which is something that works really well out of your wallet. We're taking that and we're making that feasible in an electronic way. Active Directory, of course, holds all the tokens and all the things that we have shared, and we already talked about that when I introduced the basic technologies. We have NTFS, and we already talked about that in a little bit, when we talked about those, the management of the access control entries. So NTFS is all access control entry based. So you need to manage all those claims, all those identities for who can access your disk, rather than really have a way to base this on a set of rules. So this is really pretty hard still. And then we have the Windows Communication Foundation together with the with the Authorization Manager. That's part of Windows Server 2003. And will be part of, again, of course, of Longhorn Server, which allow you to actually manage a claims-based model, and and ADFS aids in that as well. So ADFS plays in that picture. We have a way to go and have an authorization manager, which actually helps you managing those claims. It separates the identity really from the claims. Takes information bits about you, endorsed facts about you, or endorsed facts about your organization, and uses that in rules as the basis for authorization, than rather just your name. And then Active Directory Federation Services is what Steve talked about in this picture. So let's look at a few scenarios. I like the way how you're standing behind the clock.
Huh. The reason I was grumpy at your interruptions is you were not thinking about our time budget. I want to see you finish these all by yourself.
Ah, so you're standing there in
you should think of me
triumphant
as your projected superego right now, staring. But I was good. I didn't interrupt you very often.
No, you didn't interrupt me at all, actually.
And you got plenty of time, I'm sure. No worries. Everything's okay.
Now I'm worried.
Good. This is my favorite website that there's a picture of, threadless.com.
That's right.
Threadless.com is a t-shirt competition. Hundreds and hundreds of people around the world send in t-shirt designs every week. People vote on them. Thousands of people vote. The 4 shirts that win get printed. They print limited shirt runs. And most of the people who go there are only 20 and can't afford to buy too many. It's horrible when you're older and can afford them and go buy more than one a week or something. I don't know anyone who does that personally.
So when Steve shows up at the office and he wears a proper shirt, people are concerned about his health.
Or that I'm talking to a customer that doesn't want to see Darth Vader trimming a Death Star topiary.
Yes. So every day at work, Steve wears well, almost every day you wear a different, certainly every day you wear a different shirt. But the interesting thing is that almost every day you seem to wear a new shirt.
That's only because you don't keep track.
Okay.
And I'm hurt by that. You should keep track of my clothing.
You have about, I'm sure you have about 300 or 400 of those t-shirts.
But you see, even this kind of security is kind of funny because you're going up to these websites and accessing them with username password, which is the dominant kind of identity that we deal with. Clemens is aghast to find out when he comes to America that his bank requires nothing more than a username and password to do online transactions.
And there's no transaction code protection or any of that sort. Username and password gets you in, and then you can do whatever you want without any further checks. And I'm just horrified by that.
And I just told him that Americans are more trustworthy than Europeans, obviously.
Oh.
But this kind of security is really common. And of course, we're being very sophisticated attacks against it with phishing. And so the real reason that all of the standards people are moving on the card space technology, which we hope will become as ubiquitous as the protocols, is precisely to fight against using this. We need quickly to establish some other authentication mechanism which is guarded against this kind of bad security. This is basically a security mechanism that's there only because it's pretty much all you can do with HTTPS. You can establish one sort of secret that guards the entire transaction. And it's the only simple thing, and everyone uses it, and it's not sufficient. And so right now, we're in a situation where we're under a threat, where we will lose the opportunity to have internet commerce unless we secure it better. And so it's actually a very principled thing that's driving the major vendors to try to establish card space in the WS security family of protocols. And you want to think about adapting that as quickly as possible.
And I'll be happy to admit that I have about 5 or 6 passwords, which are quite long and I think quite strong, but if I lose any one of them, I'll be in trouble because I'm just using them, and as I use the one password at all sites that I don't necessarily trust. But if they figure out this password and figure out all the other sites where I am, well, then they can just use my identity.
They're on a sticker on his computer at home. His bank, since you could use this, is "Fuzzy Bunny is cute!" exclamation point.
And the exclamation point, of course, makes that strong.
Yes.
So that's the story with the websites, which is pretty weak. Outlook and Exchange have a dual factor model, if you will. You go in Outlook. Wasn't there another picture in there? No, that was. Oh, can you go back?
Clemens, you are a slow learner with these machines.
Yeah, I know. It's bad. I could bet there was another icon in there. Well, there's obviously not. So
I can't even make sense of that triangle with the chemical in it.
Really? So you log in. So there's 2 ways to use Outlook, right? There's Outlook Web Access and there's local Outlook. In local Outlook, I establish, so that's the blue lines here. I go and establish my identity with Active Directory by logging onto the machine, starting Outlook, and then the trust is automatically there between my Outlook and Exchange. In the web scenario, which is the upper scenario, I walk up to the website, and then the website goes and authenticates on my behalf with Active Directory, and then lets me onto the Exchange server. So it's all directory-based, but it's a slightly different scenario. Once I'm already in the security harness, and then on the other side, the security harness is created for me by the website.
I want to appreciate your maturity here. When icons are missing, it turns out Clemens always will tell the audience that it was the people who are working on the PowerPoints back in the speaker lounge who have deleted them. Now, every time we find that they also happen to mysteriously vanish from the copy on his computer. But that only, I'm proud of you that you didn't blame these other people for the missing icon here. I'm just,
I think we forgot that.
you say I always say mean things about you. I wanted to say something nice. And
That's very nice of you.
Thank you. You're very welcome.
Yes. But it turns out that because it's on the web, you don't have as rich authentication mechanisms as you have here. Here, the lower one, you can go and secure with your fingerprints. You can secure with all sorts of authentication mechanisms that are available to you through the platform, because you first need to get through the platform authentication, and then you are actually able to access your mail. Well, when it goes through web, Outlook Web Access, we're all back to the whole password business. So it's interesting that even at a company like Microsoft, the mail is sort of guarded by a rather weak security mechanism because we don't have anything better. Now with CardSpace, the story is changing because now we're going to have a ubiquitous infrastructure to actually make this authentication story stronger over the web. And CardSpace, mind you, is not a Windows exclusive mechanism. It's a set of protocols, and we happen to have a UI that works on Windows really well, and that's protected, reasonably well protected against phishing and other attacks. But everything that happens on the wire is well documented. It's being standardized. It's WS Trust and WS Federation and all those protocols that are going on. That's the example that Steve already talked about. The documents sitting at IBM. Steve wanting to access those documents at IBM, and there's broker trust going on between those two organizations. Microsoft manages it's Gudge actually this time. Martin Gudgeon, who's been one of the big rock stars of our specification the W Star specification process. So we used him as an example here. So his relationship to Microsoft as an employee and member of the spec group is managed entirely by Microsoft. IBM here just has information stored about a group of people, or more precisely about a certain set of claims that need to be brought to access that store. And then we have the W3C, which actually does the translation of is member of the specification group at Microsoft to is member of the W3C group, which can actually access those files. So we have a translation service which translates one sort of claim into another sort of claim, which this one can use. Once the translation has been done through this trusted third party, then Gudge can go and just access those files.
The mechanism here is kind of interesting because it shows up repeatedly, and so you can think about it constantly as the same. All of these servers, whether it's the federation server you're dealing with locally or the remote federation server or CardSpace, what they're all about is you walk up to them with a set of claims, which might include your identity and other things in your pocket. And their job is to use rules, business rules, to translate the set of claims you already have to the set of claims you're allowed to have, given where you want to go. So if I go up to a wall that guards me from some disk, it sends back and say, what you need is the blue key. And then I walk up to my STS, which might be CardSpace, it might be my federation server, whatever, my Authorization Manager. And I say, here's the claims I have now, and they need a blue key. And the job of that thing is to look through its rules and say, okay, here's the blue key. Or they give you, I can't give you a blue key, but I can give you this here thing, and you might want to go to this other STS, this other federation server, and ask for the blue key. And there can be an infinite regress of those questions, and it all can be automated because every time you either get the blue key or you get some claims that might help you get the blue key from somewhere else. And so you walk up to the original wall and the system can go from one place to another until it gets the blue key, at which case you go back to the wall and you're through, kind of like Mario Brothers for the 21st century.
So let me go and go back to the CardSpace for a moment and let's explain the fundamental principle here. While I've been talking about managed information cards and using this card thing as the Visa card or Car Club card, etc., as an example, there's a simpler story here. So let's assume you just want to authenticate at a website in the same way as you currently do with username and password. A website that you care about in some way, right? You really want to be a member of that. Like you want to be reading the New York Times, which requires you to have a password there. But you don't really want to you don't have a high security relationship with them. You just want to go and read it, and they want to have some information about you. They will go and say, what I want from you is, I want your name, and I want your address, your email address, three bits of information, first name, last name, and your email address. That's something they're going to tell you. In your personal card space, you have a card that you've issued for yourself. You have created your business card. And most of us create the business cards for ourselves, or at least it's a low security kind of thing. And you just present that card and it has the data and they're happy with it. Now the interesting thing is that card has cryptographic information associated with it, that if you present that to a particular site, it will yield a certain specific code which then doubles as your password. But you will not know about the password, and this will only show up as an identification key that can be used as some primary key for your record at the site. So you no longer have to remember a password. You don't even know the password that's associated with that site. And so we're replacing the username and the password story and this whole management of secrets with you just picking the appropriate card. And CardSpace actually remembers which card you last presented to that site. So it makes it really easy to just go and you walk up to the site and you just click through your way through. You can simply say enter, 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 and you're fine. However, it's a better mechanism than username and password. It's a much better mechanism, actually.
Architecturally, the way you think of this is that if you have a presentation logic module, you use CardSpace to let the user have a business process to pick the card themselves. And if you have a service that doesn't have a user involved, you use the Authentication Manager to do the exact same thing. So, Clemens, I thought we agreed not to have the little legs and the smiley face on the computer. Isn't there some limit for you?
But in terms of graphics?
In terms of cuteness.
Why? I think it's very cute.
I know you do. And I feel sad for you that you do. Okay, go ahead. Sorry. Oh. The little yellow lights are on? I don't know if you noticed that.
Yeah, and if you wouldn't be talking so much, I would actually get done.
Who talked a lot? I just asked.
Yeah, it's okay. So we have services which need to act on your behalf. There may be some services which will not allow you to talk to them directly, like an internal order processing system. So some services need to act on your behalf. Again, that's a story that is really hard to do currently with the identity-based model, because the identity-based model requires some form of impersonation, really acting as if it was you, and then going to that service, and as you acting, talking to that service. The SU thing makes is really difficult to almost to impossible with any mechanism but username and passwords, because you cannot really go and delegate your identity more than 2 levels deep. With claims, it's different. With claims, I can go and give you an endorsed claim, and it can be handed through, and decisions can be made based on that claim. Secure IAM is another scenario where we need that sort of trust, and Secure IAM is based on a common directory service, common shared claims. So you see, what you're seeing is there's a lot of those patterns, those simple patterns which are recurring in all sorts of scenarios. And in almost all of those scenarios, the claim-based story is much better than the identity-based story. Secure IAM, inside of Microsoft, it's really good to know who is who. But in a scenario where you have just, people are just chatting for fun, there may be a reason for not disclosing your identity, but rather just disclosing that you're a member of that network. And then we have the last example for the integration application, and that's, again, a trusted third-party scenario. We have BizTalk SSO, for instance, keeping secrets for you up in that directory, up in that shared store, which then will go and authenticate towards other services on your behalf. So again, we have all of those patterns, and they recompose again and again and again in all those sorts of environments. And most of these, and so the problem here is, again, that because it's username and password based, because it has this low security, this identity-based security model, we have some service acting as you instead of just acting on endorsed claims, acting on not your identity, not who you are, but not on rights that you possess and can give forward.
You did good, Clemens.
I think I did really good.
And I think it's only my influence and guidance that helps you do that.
Yeah, because you were standing right there, right next to the clock, so I have to keep.
And we wouldn't want to get trouble with those people.
That's right. Is that still going on?
Yes, it's going on. And today, the event that's happening this afternoon is the requirements hurl. They give you a 100-page requirements document, 100 pounds, and you have to throw it as far away as you can before you start doing the architecture.
Ah, so you're not allowed to look at it?
Well, you don't. You just get it. You don't want to be attached to it. You want to hurl it.
Oh.
And there's people far away that measure how far it went.
So the furthest you get away from the requirements, the better you are?
Exactly.
Well, that's fantastic.
And then you got to switch on to the next slide about the fact that we're going to be downstairs tomorrow.
Tomorrow, absolutely.
And you got to go to the last place, which talks about, I will send the person, perhaps, who wins this award today, and in addition to the Zen Vision, the little sticker next to Clemens' computer that has all of his passwords on it.
You wouldn't do that, would you?
No, it's a prize for the person who fills out our review and helps us become better speakers.
And one thing that should be said about this, those session evaluations is that, the better they are, the more likely it is we're going to have the same format again, because, putting six talks into the schedule of TechEd, that's a big thing.
And so that actually would be useful if you've been coming to a lot of these talks, if you would give us feedback on whether you think that's interesting. Because, of course, most TechEd talks are just one-off or two-off things. And the reason we did this is we really are trying to give you an end-to-end vision of where we're going with connected apps. But you might find it tedious beyond all saying. And at that case, you might want to tell us that so that this won't happen to you again at future TechEd.
Okay. Well, thank you for coming. And we have one more talk, which happens at 1
o'clock, I think.
At 1 o'clock in 111.
Yes, we're back home for the last talk.
Exactly.
Please ask a question. So we're going to have to talk about this. Our red light is on. And while Clemens would answer this question for 10 minutes with the red light is on, but me, I want you to come up and talk privately.
Okay. Thank you. Bye-bye.